You can take these three. All right, good to go then. Let's go. Okay, guys. I have this lab protocol out with the questions. I want to talk just a little bit about them for a second or two. When we started, we did identify the control beaker as what we needed to compare our experimental against. So I believe you guys kind of have a decent answer for that. But the second part of the first analysis question is important. It says, what variable is not used in the beaker? I'll give you guys a second to kind of focus. Bless you. What variable never goes into the control? All right. I see a lot of hands. I see some people just getting their bless you, Chris. It's okay. What variable never goes in here? Elena, what do you think? Carbon dioxide. It doesn't go in there because that's what we're actually assaying for. The second one here says, how's a control beaker serving as a standard? So how do we really compare your experimental against them? I'll give you a hint. It's real simple. You use your eyes and you do what? Color. Now, you guys might not think it is a super good way of comparing these things, but we do this in industry, right? Can you guys think of any tests that might change color and tell us something that might be available commercially or anything like that? What do you think?
Like the pH test?
Sure, a pH test, like if you're working on your pool or your hot tub or something like that. But there's other tests. Think about this works if you guys see on TV and stuff. If there's a line or if there's not a line or something like that.
Oh.
Yeah? Like a pregnancy test? Yeah, so we actually do use this in the industry. I do remember when I found out that we were going to have our first child, that line was pretty important. And it was nothing like you see on TV where they're all happy and stuff. We were like, ah. But it was fun. Well, we were planning on it. It was kind of a welcome surprise. It doesn't always happen exactly how you expect. Put it that way for us. All right, so for three says, how does the control test quantify the amount of CO2 being exhaled? Now, this is probably one of the most important questions, also one of the most difficult to do. So now we want to see how this quantifies. So we remember quantify means numbers. So how does it quantify? I'll give you a hint. You use some math. Take a shot, right?
Is it the counting?
Counting what?
Of the drops?
Of course. Just like I showed you guys in the beginning, if I only blew in there for a few seconds, we wouldn't need too many drops to turn it back to the original color. If I blew in there for 30 seconds like some of you guys, I saw some of your counts, they were in the 80s, some of you guys had 100 drops and so on. That means there's way more carbon dioxide in there. Our next part about this is going to involve exercise. And I want you guys to kind of think about this. We are going to do some trials after you guys do some exercise. So today, some of you guys were like, oh, it looks like it's going to be a little bit different. Something's changed. And I said, maybe you feel more relaxed. And some of you guys said, oh, I didn't have math today and stuff like that. Okay, that makes sense. Tomorrow, well, not tomorrow, really, Tuesday, since we have Monday off, we're going to do trials at exercise. So I'm going to force you guys to get out there and get a little exercise in. How am I going to force you guys to do that? You're ready to procedure.
Run up and down the stairs?
Run up and down the stairs. All right, so we have 2 flights of stairs. I'm going to have you go, let's go all the way down, all the way up, all the way down, all the way back up, and then you're going to do this. And you're going to do it 3 times, just like you did it here. How do you think this is going to affect your results? Jillian, what do you think?
You would end up exhaling more carbon, so then there would be more carbonic acid. You need to add more drops of like the base to turn it back thing.
So you think you're going to exhale more carbon dioxide?
Yeah.
Why?
There's more cell respiration happening.
That would make sense, right? Because you guys right now, like you were saying, you kind of relax and stuff like that. Tomorrow, or Tuesday, I'm going to have you guys going up and down the stairs a couple times. You're going to need a little bit more energy to do all that. And to get a little bit more energy, your cells are going to have to respire a little bit more. So if at rest right now you guys had trials that indicated 50, 60 drops, likely after exercise, because you guys are going to be going through way more metabolic change, metabolic rate, you're going to produce way more carbon dioxide. And therefore, likely, it's going to take way more drops. Bless you.
Thank you.
Does that sound like a good hypothesis for your lab report? Your lab reports. Yeah, I know you guys are excited. You guys have a lab rubric, right? Yeah, you do. And could you guys possibly start putting that together over the weekend? Yeah, you should, for sure. You can get all the way up through most of the analysis questions because we talked about half of them. I'm not going to talk about the rest of them because you're going to see some of this come from our second round of experimentation exercise. But I do want you guys to think about that. Additionally, I want to remind you guys in your lab reports, your rubrics, please make sure you self-assess. Start that right now. It's a big deal. And some of you guys come in and you're like, hey, do you have a copy of the rubric? Where can you find a copy of the rubric if you don't have one? If you wanted a fresh, clean copy of that lab rubric. Headline, right? So it's online. You guys print out as many copies as you want. And if I were you, I'd print out a couple extras just in case some of your peers need it. All right, I have 3 questions for you guys before we're done. Call out one of those paddles and a marker that works. 3 questions are up here. Today I want you guys to think about them real well before you guys give me an answer. I want you guys to hold up your panels when you have answered them completely. I will let you know that you guys have got this right, and that will be it, and then we will be done. So again, 3 questions up here. Number 1, what pH high or low does the indicator show? Number 2, what's the product of respiration that combines to form carbonic acid? And number 3, what pH does this carbonic acid have, high or low? 1, 2, or 3, single word answers are fine. As soon as you're done, hold them up. As soon as you're all holding them up, I will let you guys know where you're at so you don't cheat. And then we'll be done for the day. I'm waiting on 3 of you. 2.5 of you. Hold them up high. I can't see real up. Don't look so excited while you guys are holding these things up. Gio, I'm waiting on you. Helly, I'm waiting on you. Bryce is making a correction. Everybody looks pretty good so far. As long as Bryce is on board, we're in there.
I am on board.
I hope so. Let's see.
Literally.
High, carbon dioxide, and low. So, pH, high or low, does the indicator show? It does. It shows a high pH. What we're combining from respiration to form carbonic acid? Carbon dioxide. And what does pH carbonic acid has? Low. Give yourselves a big round of applause. All right, we are done. See you guys on Tuesday. Have a fantastic weekend. Guess what I forgot to say?